So let us proceed with the third example. Let's find the GCF of 35 and 200. So, let's think of a smallest number that can divide both 35 and 200. So, in order for us to think of a number, let's recall the divisibility rules. So, as you can see, 35 ends with 5 and 200 ends with 0. So, it implies that the two numbers are divisible by 5. Okay, so let's divide both sides by 5. So, 35 divided by 5, that is 7. 200 divided by 5, that is 40. So, as you can see, 7 is a prime number. 7 times 1. 40 is divisible by 5. And 40 is not present in the multiples of 7. So, therefore, the only number that can divide both 7 and 40 is 1. So, if we divide by 1, that is 7 and that is 40. Okay. So, therefore, the two numbers here are relatively prime. Okay. So, we stop dividing. F, we ends with relatively prime. So, you have now 5 times 1. So, yan. So, 5 times 1 is 5. So, therefore, the GCF for 35 and 200 is 5. Okay. Now, let's take a look at the GCF of 121 and 242. So, as you can see, it seems that they are relatively prime. But no, take a look at this one. 121 is a multiple of 11. So, if we try to look for a number that is divisible by 121 and 242, so let's try 11. Since 121 is a multiple of 11. So, let's try 11. So, 121 divided by 11 is 11. And 242 divided by 11, that will give you what? 22. So, 22. So, as you can see, 22 and 11 are what? Multiple of 11. So, we divide again by 11. So, 11 divided by 11, that is 1. 22 divided by 11, that is 2. So, we divide again by 1. So, the only number that can divide both 1 and 2 is 1. So, therefore, the two numbers here are now relatively prime. So, what will be the next step? We're going to multiply. So, 11 times 11 times 1. The product is 121. So, therefore, the GCF of 121 and 242 is 121.